And now we get to Northwest geology. Now we get to the Cascade Mountains. Okay. What formed the Cascade Mountains? Well, you probably already have a hint. Okay. But let's go over it a little bit. This, in my opinion, is one of the coolest things in all of geology. I mean, understanding how the mountains got there. Again, I'm going to kind of two plates meet, one slides beneath the other one, right? Okay, and then it bubbles up and forms volcanoes. And that's exactly what's going on with the Cascade Mountains. Okay, here we are back with Google Earth again, zooming in on the Pacific Northwest. And here, take a look at this. Check this out. I love this. I hope you guys can see this pretty well on your computer monitors. But here we have Washington State, Vancouver Island. Here's the Olympic Peninsula, right? And here's Puget Sound. And here's, the city of Seattle and Tacoma and stuff like that, Lake Washington. Uh, and then these are the Cascade Mountains, right? The Cascade Mountains, what do we got? You know which one this one is? That's the biggest one. Which one is that? That's Mount Rainier, okay? And then we got, and how about this one? Check this out. What's going on with that? Oh my gosh, look at that. That's Mount St. Helens, right? That's the volcano that erupted almost exactly 40 years ago. May 18th is going to be the 40th anniversary of the big eruption where the whole side of the mountain slid down and we go on sliding down through the river valley, right? And so that's called the Lahar. We'll get to that in a second. This is the area that the mud slid down there. Okay, so anyway, that's Spirit Lake right next to that. Well, anyway, it's not the only volcanic mountain there. We got Mount Hood, Mount Adams, Mount Hood, Mount Shasta in California. Going up here, we got Mount Baker. And so the whole Cascade Mountains, there's Baker, is a chain of volcanoes, okay? We don't erupt all that often. We'll get to it. But look at what's going on. We got this chain. It goes up into all the way down to California, all the way into Canada. And off the coast, we got the trench. And off the coast, we got the ridge. There's a transform boundary, by the way. And so what's happening then is that right here, the Juan de Fuca plate, it's called. There's a strait of Juan de Fuca. This is called the Juan de Fuca plate. And it's sliding underneath the North American plate. And then it bubbles up to form the Cascade Mountains. Okay, here's a graphic map of that same view we just saw on Google Earth. There's the trench, Juan de Fuca Trench. It's also called the Cascadia Fault. And here's the chain of volcanoes all the way on the coast. And here's the sort of red or orange colored things. That's the Juan de Fuca Ridge, and the Gorda Ridge, the Gorda Plate. I just usually simplify and think of it as one plate. It's actually three separate plates. Explorer, Juan de Fuca, and Gordo. Anyway, they're moving into and underneath the North American plate. And that's what gives the Pacific Northwest its character, really, as far as being a chain of volcanoes along the coastline there. And so the Cascade Mountains, the sinking crust, the crust dives beneath the North American plate. When it gets down deep enough, it melts. And when it comes back up, it forms the volcanoes. Okay? Write that down. That's why we have the Cascade Mountains. And we got a trench off the coast. So let's draw a diagram of that. Okay, so anyway, remember this diagram here. What you have here with the island arcs, if you have two oceanic plates slamming into each other, one slides underneath, bubbles up, and it forms islands, right? But if you have a coastline here, if you have a continental plate, well, it's almost the same thing, except for you have that granite slab of dry land. And so let's go ahead and draw that. This, again, I love this diagram. This is one of my all-time favorite ones of all of earth science. I think this discovery is absolutely amazing how they figured this out. Anyway, so you got one plate sliding underneath the other. In this case, it's the Juan de Fuca plate. Juan de Fuca plate. Okay? And this is a subduction zone. Okay. So that subduction zone, it's sliding underneath the North American plate. And so, by the way, we also have the Juan de Fuca Ridge, where it's coming out from the North America here. Juan de Fuca Ridge. I don't think I'm going to have you do that. But here's underwater. And there's a trench. Now, it's not nearly as deep a trench as you get in the Pacific Ocean. It's just not, okay? But then you got the dry land area here. There's the coast and stuff. And then as it dives down, it goes into the Earth's interior and it heats up and it melts, okay? And when it melts, mainly because it has the water in it, the moisture, when it gets to the surface, and here's what happens too, it rises to the surface, but with that moisture in there, you got all this pressure holding the moisture as basically a liquid. There's no way, it's really hot. It's in lava, so it's boiling hot, but you can't be a gas because it's compressed. It's being squeezed too tight to be able to expand into a gas. But what happens once you get to the surface, when it gets there and the pressure's released because you've reached the surface, now that super, we're talking 2,000 degree molten rock, any moisture that's in that will suddenly expand, right, to become steam, and it will explode when it. That's an eruption, is what that's called. And now ash, you probably heard of ash. The volcanic ash is not like ashes, the remnants of a burnt material. What it is, it's like a spray of liquid rock, and then the tiny, tiny particles of rock will solidify when they cool down, and so the ash is actually rock. It's powderized rock, and it's so hot. The hot air rises because it's less dense, and it goes up in the air and it goes downstream, down the wind, and ends up falling on Yakima or somewhere. Okay, so ash, when it falls, is very heavy and very dense. Now, these eruptions don't happen very often. We're going to look at that pretty soon. But this is the Cascade Mountains. And by the way, no, you don't have to be afraid of an eruption. The scientists would be able to feel, or measure, and have equipment that can detect any kind of vibration caused by the rising material. So if there's ever going to be an eruption, in the olden days, people had no idea a mountain's going to erupt. It's like, whoa, look at all the smoke coming out of the mountain. But nowadays, there's going to be plenty of warning. And so it is a safety concern, and we're going to talk about that in a second. But like I said, with modern technology, there's no way that an eruption will happen by surprise. Okay? All right. So anyway, back to the slideshow.